Hello and welcome to video 3 on programming the Nintendo Wii. So in this video I will go over how I create audio and introduce you to my SoundManager code, and I will finish up the 2D scroller here where I've actually given this game a name now. So in today's video, I will go over how we can play MP3 files for our game music and use WAV files for our sound effects. I will then go over the state machine design pattern and describe the uses of it in this game. And then I will also point out some key bits and pieces in the Wario's War game. So first off, when we create audio on the Wii, the console expects that we provide the sound in 48 kilohertz frequencies. Otherwise the sound will not play right. Disregard all of these. We will just be using the A Sound and the libmad libraries. I believe these are provided with Wii by default when you sort of download it. You will need to make changes to the makefile. I recommend going forward just to use this one as a template. The only additional things really in here are A Sound and libmad. So I'll show you the game first, and then I will talk about the SoundManager next. I have tested this on the real Wii, and it works best with a GameCube controller. After that, I would say the Wiimote and the nunchuck. Third place, I put the classic controller, and then last place, the Wiimote itself. So start off here, press A to play. So we've basically moved everything now into its sort of correct place, and then the game is more alive now with sounds in. So that's a good taster for the game there. There are the way that the game works is there are a number of like spawn waves of enemies, and each level consists of you basically living past them, and each level they'll get more difficult as the speed will increase. I'll also zoom in the text here so you can see it better if you are going to be viewing from a phone. So first off, I will just point out that I've moved the graphics and the now sound samples into an assets folder here, where you'll see there are some WAV files for the sound effects, and the music is in MP3 format. So I recommend you get Audacity if you haven't already, and you need to do things with sound here, as you should have your sound samples at 48 kilohertz here. If you I need to grab another sound effect from somewhere to demonstrate this. What shall I use? Let's grab something from the N64. So let's go for this one here. As I know for a fact it will not be in the correct format here. So you'll see here this is only 11 kilohertz here. So if we wanted this to actually be usable on the Wii, then what we would have to do is we would have to resample this to a higher frequency. Another thing to note as well is most of the sound samples I just use in mono format. So what you would need to do is you would, if it was a stereo sound, you would split to mono, and then you would delete one of the second voices, second channels, if you like. So what we need to do now is Control and A to select our sound waves here, then go on to tracks and then resample, and then select 48 kilohertz here. And then you also need to change your project rate here to 48 kilohertz. This would now be usable on the Wii. And then if you need to change the pitch for whatever reason, maybe you want it to sound slightly different, and this is the starting pitch octave here. This was at E4, so I've now changed it to D3. So here's our new sound sample here. So we will export this as a WAV file. I would stick to 16-bit PCM, and then what shall we use this for? Yeah, we'll do that. There we go, that's that one saved now. So that's how you upsample a sound effect in Audacity and export it. Again, if this was a music track, then you would export this as MP3, and then it will do all of that for you there as well. So we now have our new sound effect there. So how can we use it? So what we need to do is we have to include it. So what's going to happen is when we build this project, you'll see in here you also need to make sure that the data has the assets folder name included, which is where it will find the sound data. So our libraries here, one of these, I'm sure it supplies a converter of some sort. So you'll see down here, there are these commands here. Okay, it's this program here then is what's going to do it. So this binary to object program here is going to convert the MP3 into an object file, and it will generate a header file as well, and that header file will create a byte array, I believe, of our actual raw data, and it will also create a variable which describes how large the array is as well. So when this is built for the first time, it will generate a header file using the following sort of format. So for here it would have hit bowl. Let's make sure I spell that correctly. Bill, and then you have underscore wave and then .h. So you'll need to include the names of every file you intend to use sound wise. So you see we have the MP3s here for our game over and music here. And then in here I basically have some structs which will handle the various bits and pieces for us here. And then one thing to, in fact I'll come back to the volume bit in a moment here. So I basically create enumerations here as easy ways to reference the sound effects that I wish to play and the music as well. And I basically try and keep this manager as small and to the point as possible. There's no point overcomplicating it. Or for myself, I want to play music and I want to stop music. I want to play a sound effect, and that's it. And this is what this does here. You need to call the initialize function first. So the key thing to note here is what this relies on. So this relies on two libraries, the MP3 player and the A sound library as well. The MP3 player is obviously for playing our music, and the other is for playing our WAV files. So there are different ways you can kind of get your music data. One is from loading it from memory, and the other is loading it from the file. I will be sticking with loading things directly from memory here, as loading things from files is more complicated. And the reason why it's more complicated is because of the format of the data. When when that bin to object file creates our music, it arranges things in the correct byte order that the Wii expects them in. Whereas if we wish to load them from file system, so the SD card, when desired, then you have to format that sound in the correct way on your own. So that's why all of these will be loaded from memory. So I have like two functions here which will basically go through each of our so I have a music list and a sound effect list here, side by side these a moment. So another useful thing here of putting these in enumerations is we can then use the music max and the sound effects max to hold the size of our arrays. So they're almost kind of dynamically defined as such. And then you'll see each of these refer to this sound buffer structure here. So there's two data types in here. There is a sound size, and then this one here, which basically is a raw pointer. So to load our music files, we have to basically go over and basically populate each of the these data types here. So you'll see the sound buffer in this case refers to the music1 underscore MP3 file. So this is the data in that header file. So if I rebuild this a moment, and then we navigate to the build folder here, you'll see inside of here we have two files here. There is a dynamic array here, and there is also a size variable as well. So this dynamic array is obviously referring to the corresponding binary file. So these are the two things that we are referencing inside here. These are basically generated for us. So if we go to the corresponding like baddie file here, you'll see these names here basically are the same here, being generated in the header file. So using that, we should be able to set our data type here, our sound buffers, using the when it comes to music, we'll be using the MP3 size to set the sound size here, and then the raw binary array goes to the sound buffer, and then just increment the pointer after each song here. So that's how we have our music there, and obviously make sure you put these in the order you expect them to be in as well. So in this case here, track 1 is here, and then the game over sound music is there. So we added in an extra sound effect, our hit bullet bill one there. So we'll just copy those, come up to the name here, and then copy that. And then we'll copy that. And that is our new sound effect added. So let's go over the functions here, and I will explain them. So first off, I have like a boolean here to indicate whether the music is playing or not. Usually I kind of try and keep like two states of music. I'll have like one where we have music tracks which will be looping, and then another where the music might be playing once. For example, game music, you normally want that to loop, whereas if it's like if you had level clear music or game over music, then it would be a song you would only want to play once. And this is where this boolean is useful here, as there is a sound update function here, and then each sound update we are basically checking whether the music is actually being played or not, and if it is not playing, then we check to see whether we have it's set to loop or not. If it is, then we'll play the song again. If not, then we will leave it be. So our two sound library players we need are a sound init and MP3 player init. And then this is where my volume types come in here. So in the MP3 player here, if you open up the header file, okay, that's not a. This is the key sort of functions in here. I must have found the volume out through trial and error a while ago. I've been using this sort of code for some time, number of years now. It's a case of once you get it once, there's no need to try and reinvent the wheel. It works fine, so I kind of haven't played around with it. So the volume set in here is basically from 0 to 255. And then the music volume where have I defined that? Is that up here? Okay, that's in here. That's not one of my defines. So you can also check out the A sound lib header here for some info. They have been good and included some info here. So I probably could have just done that there, it's the same thing. So I basically set up the music volume here, and then is that one mine? Yes, it is. So I basically have like just some stuff here with some local sound states in. So as this is provided here, if for whatever reason you needed to sort of get at the volumes of various things or the state of whether something's playing or not, then that's all contained in there. And then you'll see here we've obviously loaded the music there after we've initialized both of the players, set the MP3 player volume to max there, and then we've recorded local volume states there. So once we've done that, then everything is pretty much good to go. What we need to do is to play a track. So what's happening here is the MP3 player has a function for is the sound playing or not. So what I do here also is I will do a check for myself to make sure the music track ID is in the range here. If it is, then obviously I'll play it. If not, then I'll throw an error here. So usually what I'll do is if a song is playing, then I'll tell the MP3 player to stop first. And then to play a sound, we need the sound buffer here, and the track ID here. And what is the last parameter? I think the last parameter might be a callback or something. Not too sure. Anyway, I passed null in there anyway. And then I just set the local states here. So we set it to we set the song to playing, and then if it should loop, we set the sound mode to loop, otherwise play once. So that's the key play music one there. To play a sound effect, we use the asound library for this. And there's a few different extra parameters we need here. So the one thing I do here, so I'll bring up this function here. So there's a description about each of the parameters here. So you see, you need to provide like a voice slot for the sound here. So this can be anything from 0 to 15 in this case. But they also provide this function here, which basically gets an unused voice. So I basically pass that in. I really can't remember where I found how to use the asound library from, because if you look at the demos or the examples provided, there aren't any now. And then one thing to note here as well is you have to put in what format. So this is a mono 16-bit sound, and it is a lesser Indian. So that's one thing to keep in mind as well, is the format that the Audacity outputs is Little Indian here. So if you was using a different conversion program, you might need to change that to BE if it was in Big Indian format. And then we also need to get the audio rate. Come down to that function. Where is it again? So these are all of the parameters here, and this is what I put in them. So I basically let the sound library get the audio rate. There's like a sound effect delay between playing sounds. You see here it's in milliseconds here. So all I have here is chose this for some reason. I don't remember now why I chose that. Yeah, it appears to work fine though, so I have no issues there. And then we have our sound buffer we need to pass in. We then need to pass in the sound size, and then it expects a left and right volume setting for the sound effect. As I am playing it in mono, I just pass in the sound effect volume here. And then the last parameter, the last one's just a callback, which I pass in a no parameter there. And that's how I play the sound effect. Nice and simple, and I have had no issues with it. And then the sound update one here. All we're doing in here, like I said before, is checking to see whether a song is playing or not. And then we also, if I think a song is being played, as in we've specifically said we are playing a song, then I will check to see whether the MP3 player has stopped playing it or not. And then I will update that state in here. And then if the sound is a play once sound, then obviously I will return, do nothing. However, if it's a loop sound, then I will play the active track again. And then there's also a function in here for the MP3 player to stop here. And then an important thing is to quit this at the end of the game when the player exits, so that the appropriate libraries can then release everything. So that's the sound players there. So I will now describe the state machine pattern. Not save any of that. So our first step in here the key backbone of any game is basically your main game loop in the first instance. So what I always have in there is a state machine. The state machine that I use is usually my main state, and I always have 2 title screen states and 2 game states. So I'll have an initialize part and a run part. Again, depending on your needs, you can obviously add in as many states here as you wish. I usually stick with these 2. And then each state I have 2 functions, or rather for each state there is a function and 1 function, which is usually declared externally in another module. So if I bring this up here, I have a GS defined game. So GS I usually have for global states, and then each main state as an accompanying header file as well. And then obviously the game main state is declared in here, and I always have like a high score as well defined normally. and a global high score variable here as well, as you always need a high score to beat. So let's jump into the main loop here, and then in here we have our state machine. It's simply a switch block, and this means that only one of these should be active here, so you shouldn't have any states falling through in the cases here, as the key thing of a state machine is the machine should be in only one state at any one time. So you'll see here we have our, if our game is set to title screen initialize here, then it calls the title screen initialize function, and then it updates the game state in here. I usually have the initialize functions automatically update the game states themselves, as the initialize part is usually only called once, and I usually just have that to basically clear anything up and load anything new in at that stage. So if we now open up the title screen here, you'll see in the title screen header file there is nothing much going on, and that's intentional. It shouldn't include the main inside the header file here, just in case anything else needs to call the title screen for whatever reason. There shouldn't be any reason why anything else should gain access to the global main state ID, if you like. And then in the title screen here, we have our main state initialize here and our main state run. So you see all this is doing here is this is just setting stuff up. Which in this case it just draws the backdrop for one frame. It will start the game music here, set it to looping, and then inside the title screen there is a blink message timer, which I usually have to tell the player to press a button to play. And then if you have a high score, then it will display the new high score. And then in the title screen run part is where I do the main bits of the title screen here. And then the key bit to note here is if the player presses a start button, then this is where you basically change the main state to game initialize here. And it's always important to clear the buttons that you pressed afterwards, especially if it's a was key pressed function, as this relies on the last key press values. I won't dwell on anything else in the title screen. Check it out in the code. There's nothing magical in there. So the other thing of note in here is the game header. Now the game itself, it has a couple of state machines itself. One main use for A state machine is a handling user interface. So in here I basically have a state machine for the messages themselves. So when I want to display a message, I use a state machine to handle that. And the game states themselves. So in here, these are main states. And then in the game, they are obviously game states, which are independent from one another. So in the game states, I also have substates of these game states. So internally in the game, each of these states has their own function. Rather than splitting these into two here, like in the main bit here, instead I have a substate which can be either set to initialize or run, or obviously there's also a max one as well. And that's because each of these game states, sometimes they need, the first time they're called, they will need an initialization phase to occur. And then they'll have a run phase. Some of these will have like a timer inside of them, which needs to be set. For example, with the various messages here, so get ready, level up, game over, pause, and game one, these all have messages associated with them. And when there is a message that needs to be sent to the player, then we will usually have an initialize and a run state in there. So the initialize state will have the message state manager be initialized and the timed event to be set up. And then when it runs, the timer will count down. When it reaches 0, then that state will automatically be changed to another state. Unless, of course, the player presses a button to skip that state. So if I jump in here, I will skip straight down to the main state functions here. So you'll see we have the game init function here. Very basic. We basically set the level to the starting level, set our lives to 3. Again, feel free to add however many lives you want to have for your game. And we set the score to 0 at the start. And then we set our substate to initialize and the game state to new level. And then that's it in the game initialize here. Obviously, depending on what type of game you have, you might wish to do a lot more in here. And then the game run is basically a core state machine here. Each individual game state is literally split into its individual part. This keeps things nice and clean and ordered. So if you wanted to add another state in here, it's just a case of bunging a new game state in here, in the enumeration here, and then just putting a new case and break inside the switch block here. So I'll quickly look at a few of these. So when we start a new level, I'll keep not using this one, as it's only usually two states, 0 or 1 normally. So the substate isn't actually used in the new level bit here, as the new level thing doesn't actually need to convey anything message wise. All it does is it basically initializes all the key managers of the various game components. So the EM here is the explosion manager. I usually try and keep these names very brief. BM is the bullet manager. CM is the cloud manager. PL is the player. BUL is the bullet manager. And BB is bullet bill manager, or just bullet bill. And then there's also a game variable here for how many waves of baddies you should have to fight your way through per level. So you'll see here I have a constant start number that there should be, and then depending on what level you're on, they add an extra wave here. So this is just to increase the difficulty. And then in here there is a function called draw game scene, and this is basically the order that all of our objects should be drawn in. So we draw a backdrop first, then we draw the clouds below everything, then the player, then the baddies, then the bullet bill, then the explosions, then the bullets, and then the top cloud layer, which goes over everything. And then the very last thing, we draw the game heads-up display. So what that is basically is our score, our lives, what level we're on, and how many spawn waves we have to fight to complete the level. So let's see which one is which one should we go over next. So that was a new level there. When we reset the level, we're basically just calling the same one again. You could have an individual level thing there. I decided not to do that in the case of this game here. So the first one we'll get to is get ready here. So this uses the substates here. Anything with a message basically uses the substates, and the reason for that is we initialize the message manager, and then we usually I'll set up like a timer to tick down, and then this miscellaneous timer, if it reaches 0, then it will transition to the next state automatically. So you'll see if this one is completed, then it will set the substate to substate max. However, if the player presses the A button, it will also set the substate to substate max. So in this case, the player is able to skip the get ready message should they wish. And then it's always important in each of these stages here, or these states, we always need to draw the game scene. Otherwise you end up switching to a state where nothing is drawn and the screen goes black. And then in each of these, whenever we also have a message, the update message should be called last. And the reason for that is it's basically got its own state machine in here with its own blink timer to blink the message. And then depending on what the active message ID is in here, depends what message it actually draws. So if you don't call this last, then something potentially will be drawing over the top of the message. Again, everything is dependent on the order that you draw it in. So that's the get ready function there. And then you see once the substate is set to substate max, then the substate initialize is set, and then the state is set to play. So I will quickly go over the play code here. So for all of the other game objects or actors, so the player, the bullets, the explosions, what have you, I basically covered that in the last video. The only difference is some of these have now been put into their own modules to separate them, which is kind of what you want to do in large projects, to basically try and containerize all your actors. So either like for the player, for example, they now have their own header file with some little functions here. So the player in this, the update function they basically take a move order command, and these are defined in the utilities header here. So the reason why these move orders exist is because just like the desktop PC, there are obviously a number of different controllers you could have connected to the Wii. So we basically need to check various different input devices first to try and resolve or understand the player's intent, depending on the controller types. So we don't want the input to occur inside the player module. We just want the intent to be passed to the player. So in here we have a move order variable, and also in here we have a function called update controls. At the start here, the move order is set to 0, and then we basically just check what controller type is connected, and then we check the various sticks if it has a stick, and then we update the move order. And then we also have the buttons pressed as well here for fire button or start button or whatever. So one key thing to note here is although we have like a global key code for start, the Wiimote itself obviously has no start button. So in this case I use the plus button to represent that. So if I get back to here now, so we have a variable in here which basically checks to see how many how many baddies we have left. So we take a number at the start before we update everything. So you'll see in here we also hand over pause button as well. If the player presses the start button, then we pause the game. We set the substate to initialize and the state to pause, and then we play a sound effect. So we can put our new sound effect in here actually. So that could be our pause sound effect now. And then we basically update everyone here. Afterwards we check to see whether the player's been hit by Bullet Bill. If they have, so the player has like a state as well in here. So yeah, state machines used everywhere, very useful. So in this case for the player should only have one state. And the states that they can have. Again, are these. So we have dead, dying, alive. You could have anything else in here. What you can think of basically, maybe the player jumps or does some other magical thing. Again, add in a state for it. As long as there is only one state that they can be in at any one time, then a state machine fits the bill. So you see there's a collision rectangle which is set in the player code. So if the player hits Bullet Bill, then we set their state to dying. If he hits a baddie, then his state is set to dying. And then there's also the player themselves in the update function. There is also the player checks with the bullet manager itself to see whether it's collided with an enemy bullet or not. And then if the player state is not equal to alive, then we set the state, the game state to die, and we initialize the substate. Whereas if we get past this, then obviously the player is alive. We check to see whether the player killed Bullet Bill. There's a boolean in there basically. The way that he works is he has like a load of lives which get which tick down if you manage to fire and hit him with a bullet. And then if he was killed, then set that to false afterwards, so that this is not picked up again in the next update loop. And then this variable score is like a local one in here, which we add various things to. And the reason for this is there is like another thing in here. There's a new life counter, which is based on how much score the player actually gets. And if you reach that threshold, then you will gain an extra life, which is a nice little touch to put in some shoot 'em ups. And then there's also one for if you killed any of the normal sort of baddies. There is a variable in there as well, which counts each update of them, whether any of them have basically hit a bullet. And if they have, this variable is incremented internally, which you can access in the game here, and then also increase the score here. So we should also be increasing this in here as well. So thankfully I've just found a bug, missed out the adding the score here. And then if our new life counter here is greater than the game's defined extra life counter, which is 2000, then we subtract this value from our game counter to reset it, and then we add a new player life, and then probably should have a sound effect specifically to indicate to the player that they've got an extra life. And then this is to basically check to see whether we've cleared the level here. So if we are alive, if the player's alive, and then if the player count, the baddie count is now 0, but the ode count is 1. So that's where this comes in here. We check before everything updates how many baddies are left, so that we can later check to make sure that the number, if 0, was 1 previously. And then we can subtract a baddie count wave. If the wave reaches 0, then we add 100 to the score. And you notice that this is not included in here. And then we basically level up. Or we reset the baddies. Bullet Bill resets on his own. And then of course we draw the scene at the end here. So that's all I want to sort of go over here. Check out each of the individual parts to see how it was implemented. And yeah, I don't think there's anything else I really need to sort of go over. There's all of the movements for everything was kind of described in the last video with the lookup tables. So yeah, that's it for this video. I will be going into 3D on the Wii in the next videos. So I shall catch you in the next one. Any comments, leave them below, and I will get back to you when I'm online next. Thanks for watching.